Alright guys, last video of the week. Only got two problems to do, but they're different than some of the ones we've been working on. So you take a look at this, and we got obviously sine and cosine. Notice there's no way to make a substitution because we don't have sine squared or cosine squared. They're just sine and cosine. So you got an issue here. All right, now one thing we could do is manipulate this so that we have sine squared and cosine squared. And we could do that by squaring both sides. Now the problem is if you leave it in the form it is and we square the left-hand side, you'd get a sine squared, a cosine squared, and then you'd get a term with sine and cosine in it, which doesn't work out so well. Okay, so why not isolate sine on one side and cosine on the other and separate them? And therefore, when we square both sides, we're going to get a sine squared on one side and a cosine squared on the other side. Okay, so one of these two has to move over to the other side. I'm going to choose to move this guy over because then I'll have less negative signs. Okay, so when I move that over, I get sine of x equals 1 plus cosine of x. Okay, and then if I square everything like that, okay, the left-hand side becomes sine squared x equals, now the right-hand side I got a binomial, okay, so I got to use my formula for squaring a binomial. So the first term squared, 1 squared is 1, plus 2 times the first times the second would be 2 cosine of x, plus cosine squared, so I get cosine squared of x. Now, the problem we run into here is we could get extraneous solutions. Okay, this goes back to when we were working on solving radical equations, where you had to square both sides. And anytime you do that when you're solving an equation, you could form extraneous solutions. So whatever solutions we come up with, we have to go back and check them. Okay, so I take a look at this, and I say, okay, what am I going to do with this? Notice over here on the right-hand side, I've got something that acts as a quadratic term in cosine, and something that acts as a linear term in cosine. So over here on the right-hand side, I got to be thinking, well, I might have some sort of factoring pattern, okay, in cosine. Okay, so why not get rid of the sine squared? Okay, so we go back to our sine squared x plus cosine squared x equals 1. So sine squared x equals 1 minus cosine squared x. And why not take this guy and substitute it in there and see what happens? Okay, so this is 1 minus cosine squared of x. 1 plus 2 cosine of x plus cosine squared of x. Okay, now we take a look at that and we say, okay, well, let's put it in some sort of standard form. Now notice right here, the ones cancel each other out. Okay, so all I got to do is bring this guy over, okay, and collect it with this cosine squared of x. Okay, so I get 0 equals, all right, cosine squared plus cosine squared is 2 cosine squared of x. And then I have this guy right there, plus 2 cosine of x. All right, now notice with this, you've got a GCF you can factor out. And that GCF is 2 cosine of x. So I factor that guy out. And I'm left with cosine of x plus 1. Okay, and that's all you can do as far as factoring. So we say, okay, well, if that's the case, then 2 cosine of x equals 0, or cosine x plus 1 equals 0. Okay, well, if this is the case, that would mean that cosine of x equals 0. And if this is the case, that would mean that cosine of x equals -1. So we go to our unit circle, and we say, okay, when is the cosine 0? Okay, so remember the cosine is your x-coordinate, so that happens at pi over 2 and 3 pi over 2. Okay, so the solutions here would be x equals pi over 2 and 3 pi over 2. And then we say, okay, when is cosine equal to -1? So once again, we go here, and the only time our x-coordinate is -1 is at pi. Okay, so this guy would give us x equals pi. Okay, so we got 3 possible solutions. We got to check them. Okay, so we check these guys. And just go back up to this original one. Okay, so I'll check pi over 2. So we go sine of pi over 2 minus cosine of pi over 2 equals 1. We say, okay, does that work out? So let's see. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. Okay, so I get 1 minus 0 equals 1, and obviously that works. So this guy is a solution. Okay, so now I check 3 pi over 2. Okay, so sine of 3 pi over 2 minus cosine of 3 pi over 2 equals 1. We say, okay, well, sine of 3 pi over 2 is -1, and cosine of 3 pi over 2 is 0. So we get -1 minus 0 equals 1, and that would be a no-no. So this guy does not work. Okay, now I just got to check pi. Okay, so we say, okay, sine of pi minus cosine of pi equals 1. And so we say, okay, let's go here. So sine of pi is 0, and cosine of pi is -1. So I get 0 minus a -1 equals 1, and that is a yes. So that guy works. So those are your 2 solutions. Okay, so once again, with what we've been doing, okay, if we solve on the interval from 0 to 2 pi, I'm going to get x equals pi over 2, and I'm going to get x equals pi. Okay, and if we solve on the set of real numbers, I'm going to get x equals pi over 2 plus 2n pi, and I'm going to get x equals pi plus 2n pi, where x is an integer. Okay, so that guy's a little bit different than the one we've been working on. So let's try one more like that. And let's just change the minus to a plus. And let's see if it makes a big difference or not. I don't know. Okay, so we go about it the same way. I'm going to move one of these 2 over to the right. Technically, it doesn't make any difference, because if I move cosine over, it becomes 1 minus cosine. If I move sine over, it becomes 1 minus sine. So it doesn't seem like it really makes any difference. So I'll just choose to move the cosine over there. Okay, so we get sine of x equals 1 minus cosine of x. And then we square both sides. And remember, when we do that, okay, you got to think in terms of extraneous solutions. Okay, we might have an issue here. Okay, so let's see. We're going to get sine squared of x equals, that would be 1 minus 2 times 1, 2 cosine of x, plus cosine squared of x. Okay, so I'm in the same boat as the last one. Okay, so why not make that substitution, okay, where we know that sine squared of x is equal to 1 minus cosine squared of x from our Pythagorean identity. Okay, so I get 1 minus cosine squared of x equals 1 minus 2 cosine of x plus cosine squared of x. Okay, and again, the 1 and the 1 cancel each other off, and so we bring this guy over and collect it. So I get 0 equals 2 cosine squared of x minus, you got a minus sign there, 2 cosine of x. Once again, you have a GCF, and the GCF is exactly the same, so it's 2 cosine of x. And I'd be left with cosine of x minus 1. in there. Okay. So let's see, this would mean that 2 cosine of x equals 0, which would give us cosine of x equals 0. And this would mean that cosine of x minus 1 equals 0, which would give us cosine of x equals positive 1. And then we go to our unit circle. Cosine is 0. Once again, that happens at pi over 2 and 3 pi over 2. Okay? All right, so this gives us x equals pi over 2 and 3 pi over 2. Cosine equals 1. Okay. Now remember, last time it was cosine equals negative 1. That was over here at pi, but now it's positive 1, so that happens at 0 radians. Okay, so this gives us x equals 0. And then we got to go check. Okay, because remember, we got to worry about extraneous solutions here. Okay, so we check these guys. Okay, so go back up to the original one and just check all 3 of those. Okay, so I say sine of pi over 2 plus cosine of pi over 2 equals 1. And then I go to my unit circle. What's happening at pi over 2? Well, sine is 1 and cosine is 0. So you get 1 plus 0 equals 1, and obviously that works out. So we're going to hold on to this guy. Now let's check 3 pi over 2. So we say sine of 3 pi over 2 plus cosine of 3 pi over 2 equals 1. Okay, so again, we go to 3 pi over 2. And we say, okay, well, let's see. The sine is negative 1 and cosine is 0. So I get negative 1 plus 0 equals 1, and that's a no-go. That doesn't work out. Okay, so let's see. So this guy goes away. Nope, don't want him. Okay, and we got to check 0. Okay, so we say the sine of 0 plus the cosine of 0 equals 1. Take a look here and say, okay, the sine of 0 is 0, cosine of 0 is 1, so I get 0 plus 1 equals 1, and that checks. Okay, so we get this guy as well. So notice we get the same 2 solutions here, okay, as the last one, even though the equations are slightly different. Okay, so let's see, on 0 to 2 pi, okay, we get x equals pi over 2 and x equals 0. We got that last time, didn't we? Oh no, we got pi over 2 and pi. Okay, not pi over 2 and 0. Okay, so let's see. Right here, okay, when we go the set of real numbers, I would get x equals pi over 2 plus 2n pi. And I would get x equals 0 plus 2n pi, so that's just 2n pi. Okay, where obviously n is an integer. Okay, that wraps it up. Okay, I would say that my 3 musketeers and their sidekick D'Artagnan from 7th period better take a look at your quizzes. I left you a message. I haven't heard anything back because we got some bonehead mistakes in there. Okay, so you might want to take a look at that and take a look at the hints and go back and fix those things. Otherwise, you guys have a wonderful summer. I miss all of you. I'm going to miss all of you all summer, and I'll look forward to seeing you next year.